Hi friends, in this video we solve complex integration related questions asked in TRB exam. Right? The first question is the value of contour integration e power 3z divided by z plus 1 whole power 4 dz where c is mod z is equal to 2. Right? This is what question. So this we can solve by using Cauchy's integral formula. What is Cauchy's integral formula? It states that integral c f of z minus z naught whole power n plus 1, this is n plus 1 dz is equal to 2 pi I by n factorial f n z naught. Right? So this is what Cauchy's integral formula. Compare this with the given equation. So integral c e power 3z z plus 1 whole power 4 dz. This indicates what is f of z? F of z is equal to e power 3z. N power 1, n plus 1 is 4, so this implies n is equal to 3. Compare these two. Right? So it is z minus z naught, so I can write z minus minus 1, so z naught is equal to 1. So these things we have to find. So instead of evaluating this integral, what I need to evaluate? Only this one, right hand side, right? That is very simple. So instead of evaluating this, what I have to evaluate? 2 pi I divided by n is 3 factorial f 3 z naught is minus 1, not plus 1, it is minus, right? Z naught is minus 1. This only I have to find instead of this value. So I have everything. Only what I need is f3 dash. It is triple integration, right? So n is equal to 3, so it is 3 dash. Okay. So what is f of z? F of z is equal to e power 3z. What is f double dash of f dash of z? 3 into e power 3. Differentiate it. F double dash of z, again differentiate, 9 into e power 3. F triple dash of z, that is equal to 27 into e power 3z. What I need is f triple dash of minus 1. F triple dash of z is equal to minus 1. So that will give 27 into e power minus 3. So instead of evaluating this, I have to find this only. Okay, so the answer is integral e power 3z divided by z plus 1 whole power 4 dz is equal to 2 pi I divided by 3 factorial. 3 factorial is nothing but 6 into f3 dash of minus 1, so that is 27 into e power minus 3. 27 into 2, 54, 54 by 6, 9 pi I, e power minus 3 is divided by e power plus 3. So the answer is 9 pi I divided by e power plus 3. So 9 pi I divided by e power plus 3, option B is the correct answer. And the next question is, what is the thing? So the value of closed integral c sin pi z square cos plus cos by z square divided by z minus 1 into z minus 2 dz, where c is a circle, mod z is equal to 3. This is also the same problem. Here you see the order of the pole is 4, right? Here we have 4. But this is simple equation, right? So here it is power 1. Right? For power 1, what is Cauchy's integral formula? It is simple. F of z divided by z minus z naught, Cauchy's integral formula. I write directly. dz is equal to 2 pi I into f of z naught. Right? So this is for power 1. Right? So power 2 also you have to remember. Up to power 3 or power 4 you use the general formula. So now what I have to find, I have to compare these two equations, right? But here you see I have only z minus z naught, no multiplication. So I want to split this denominator. So how can I split this denominator? Take partial fraction. So first I take partial fraction of 1 by z minus 1, z minus 2. So take partial fraction a by z minus 1 plus b by z minus 2. If you simplify, what you get is 1 by minus 1 by z minus 1 plus 1 by z minus 2 So that will be equal to 1 by z minus 2 minus 1 by z minus 1. Now you substitute, instead of 1 by z minus 1, z minus 2, you substitute this one. So I rewrite the given problem, right? C, fine. 1 by z minus 1, z minus 2, I write as 1 by z minus 2 minus 1 by z minus 1. Numerator is common, right? Because I split the denominator only. So numerator is sin pi z squared cos pi z squared. Sin pi z square plus cos pi z square into dz. So now I can split, right? How can I split? So integral C sin pi z square plus cos pi z square divided by z minus 2 dz minus C sin pi z square plus cos pi z square divided by z minus 1 into dz. Fine. Okay, now it is a simple formula. So what is the f? Compare with the general equation. This is f of z, right? This is what my z naught, because f of z by z minus z naught dz. So this is also f of z in the numerator. Denominator, this is z naught. So if you compare this equation with the Cauchy's integral formula, numerator is f of z, denominator is z naught. So that is equal to 2 pi I f of z naught, right? So I have to write, so this is equal to 2 pi I f of z naught. So that is equal to 2 pi I f of z naught is 2 minus, this is 2 pi I f of z naught is 1. So f of 1. Right? So what is f of z? For both the case, f of z is equal to sin pi z square plus cos pi z square. So first what I have to find f of 2. So f of 2 is z square sin 4 pi plus cos 4 pi. Right? So sin 4 pi, cos 4 pi is 1, sin 4 pi is 0. So it is 2 pi, 1 only. Similarly, what is f of 1? Sin pi plus cos pi. Sin pi is 0, cos pi is minus 1. So 2 pi I common for both. F of 2 is 1 minus, f of 1 is minus 1. So answer is 4 pi I. So which option is correct? Let us see. Option D is the correct answer. Fine. And the last question is, this is also asked in TRB 2016. The value of integral, closed integral C tan z dz, where C is the circle mod z is equal to 2 is. Right here, we can use Cauchy's integral formula, but it's critical. But because Cauchy's integral formula, if it is having just now only I have seen f of z divided by z minus f of z divided by z minus z naught means we can go right 2 pi I into f of z. But here we don't have denominator, z minus format is not there, so we go for Cauchy's residue theorem, right? So if you want to solve this problem, we have to apply Cauchy's residue theorem. What it is telling? Cauchy's residue theorem. It states that closed integral C f of z dz is equal to 2 pi I into sum of residues of f of z at z1, z2 up to z. This is what Cauchy's residue theorem. So if I want to find this answer, I need only residues. So first I find the residue of tan z, right? So what is my f of z? F of z is tan z. How to find residue? I told already, right? So if you want to find residue, simplify this numerator and denominator, sin z by cos z, right? So what is residue? Residue is a function which value which makes our function infinity. So in this, when z is equal to plus pi by 2, what will happen? Cos pi by 2 0, so the function will become infinity. When z is equal to minus pi by 2, cos of minus pi by 2 also 0, so it will become infinity. Like that, plus or minus 3 pi by 2, plus or minus 5 pi by 2, it will go. But our formula, our problem indicates mod z is equal to 2 only. So mod z is 2. Mod z is equal to 2 means whatever the value of residue, whatever the value of z which lies within the 2, we have to take into account. So here you see, except mod z is equal to plus or minus pi by 2, all the values are greater than 2, right? So only this one we have to take into account. So residue we can find. So what is the thing is, I find the residue of f of z at z is equal to pi by 2, right? So how to find residues? I have put one video and solved the TRB question, that also very important. So first you see this if you don't know. Residue of f of z, z tends to a is given by limit z tends to a. This is a procedure to find residue is z minus a into f of z, f of a, right? So what is the thing? F of z is, we know. What is f of z? F of z is tan z. So a is pi by 2 here. So residue of f of z, z is equal to pi by 2 is limit z tends to pi by 2, z minus pi by 2, f of a, that is sin pi by 2 divided by cos pi by 2, right? Okay, so sin pi by 2 divided by cos pi by 2, so it will become infinity. So what I need is, you see, when you substitute pi by 2, z is equal to pi by 2, it will become 0. So anything multiplied by 0, 0. So numerator is 0, cos pi by 2 is also 0, right? So it is 0 by 0 format. Sin z is equal to pi by 2 means this will become 0, multiply by 0, numerator is 0, cos pi by 2, denominator is also 0. So I apply L'Hospital rule, z tends to pi by 2, z minus pi by 2, numerator I differentiate separately, or denominator separately, differentiate separately, so what I get is 0, right? So otherwise what you can do, you can do it in different way. Simply you can put r limit z tends to pi by 2, z minus pi by 2 into tan pi by 2, z pi by 2 means always it will be 0. So the answer is 0. Similarly, for one residue is 0. Similarly, residue at z is equal to minus pi by 2. Again, what will happen? Limit z is equal to, z tends to minus pi by 2, z plus pi by 2, tan pi by 2. Again, it will become 0. So both the residues are 0. Then what is the condition? You see, as per the Cauchy's residue theorem, 2 pi into sum of residues. So 2 pi into sum of residues, what is the thing? 0 only. So integral tan z dz c is equal to 2 pi I into sum of residue. First residue 0, second residue 0. So the answer is 0 only. So what they have given, is there any option? Let us see. No, 4 pi I minus 4, 2 pi. So the option is none of the above, right? I hope you understand all the problems. So to explain this, I have taken this much time, but in exam you can solve so fast, right? I hope you understand. If you have any doubt, please ask me in comment section. Thank you.